it is my great honor to introduce Dr. David Parker, who is the director of ESA's Human and Robotic Exploration Division. And Dave really was very kind enough to give us time in his very, very busy calendar, and he'll explain why it is busy in his presentation. But I had a sneak preview of his talk, and I was just so excited and inspired, like always, Dave. So I really am looking forward to your talk and sharing your thoughts with the community as to what they should look forward to in the next decade.
Thank you very much, Mahesh. Good morning, good afternoon, good evening, wherever you are. Thank you very much for the opportunity to join in this third virtual edition of the European Lunar Symposium. It's a great pleasure to be here. Actually, I'm back in my office, which is great, back in my office in ESTEC rather than sitting at home. But I hope I can kick this conference off with a bit of a perspective on Europe's space exploration program and our thoughts about the future of lunar exploration in particular. So here we go. The moon within Terra Novae. Terra Novae is the name we've now given to the European Exploration Envelope Programme, which is the programmatic structure within ESA that delivers our exploration activities. It's one of the optional programs of ESA. It's about 13% of the overall annual financial budget of the European Space Agency. Terra Novae means new worlds in Latin, but it also metaphorically means new possibilities, new opportunities for knowledge, for commercial opportunities, and new opportunities for inspiration, as kind of characterized by this little cartoon of the human explorer and her buddy robot exploring the moon. So ESA's exploration program is about expanding places where human beings live and work. We have been living and working now for 22 years off-world aboard the International Space Station. Right now, there's a European astronaut with an Italian passport, Samantha Cristoforetti, undertaking her second mission aboard the International Space Station. The ISS being a place where dozens of astronauts have carried out hundreds of experiments on behalf of thousands of scientists around Europe and indeed around the world for the past 22 years. It's established the fact that human beings can live and work off-world, and also prepared us to go further, and the further place is obviously to the moon. The moon is the next place where we believe humans will live and work, supported by their robotic buddies. But we don't forget that we have the horizon goal of Mars as a destination for human exploration. All these three destinations have their value and their place. Right now, humans are living and working in low Earth orbit. We will have a partnership of humans and robots in the moon, lunar exploration in the next few years. But for the time being, it's robots exploring Mars. But much of what we're doing, both in low Earth orbit and the moon, is also preparing us for this further and more distant journey. This illustration is also showing you some of the elements of the Terra Novae program, the things we're doing today, and perhaps some of the things we hope to do in the near future. And I'll say a bit more about each one of those as we go through. But I always start by asking the question, why are we doing exploration at all? It's not a single explanation. There's not a single rationale for space exploration. Our program is inspired by the Global Exploration Strategy Framework document of 2007, which set out essentially four reasons for space exploration. Scientific exploration, the use of low Earth orbit, the understanding the moon, and also of Mars is, of course, driven by a scientific impulse, the search for new knowledge, both of our solar system, but also knowledge that we can use back here on Earth. That hints at the second element, which is the impact of space exploration back here on Earth. I always say that space exploration is a unique combination of curiosity and opportunity. The curiosity to venture out into the unknown, and the opportunity to bring back to Earth skills and capabilities which actually help us back on Earth. we have dozens of examples of how science and technology from aboard the space station are helping us back here on Earth day by day. And I'm utterly convinced the same is true of lunar exploration and one day of human Mars exploration. So there's an economic impulse of what we're doing as well. And part of that is to tackle the global scale challenges we have, whether that be climate change, whether that be the search for more sustainable energy, or indeed the challenge of developing a scientifically, technologically literate next generation. And that inspiration of space exploration is headlined, if you like, by our astronauts. But much of what we do with our robotic exploration as well is inspiring the next generation. And part of what we want to do is to pass the message that global cooperation, that the search for the search for solutions to challenging objectives is an inspiring goal in itself and brings value back to the next generation. So having said all of that, what is our space exploration program? We call it Terra Novi. The European Exploration Envelope Programme is the techno name, if you like. It was launched at the 2016 ESA Council ministerial meeting with the first €1.5 billion of investment. And we secured at the second round in 2019 ministerial a significant increase of the investment to €2 billion for the period just coming to an end now, 3-year period. In period 2, we organised our programme as 4 exploration campaigns, 4 cornerstone campaigns supported by enabling technology and the essential element of scientific utilisation. But we have an increasingly important cross-cutting theme of commercialisation, which is very relevant in low Earth orbit already, but increasingly so also to lunar exploration. Now, this is where I draw breath, because we have an ESA Ministerial Council meeting coming up later this year in Paris. And my boss has given me the challenge to raise €3 billion of investment, so a 50% budget increase compared to the current period. And that's an enormous challenge, and I need your help to make that happen. I can't do it on my own. I need you, the community, especially in Europe, to say that space exploration is important, to say that Europe should have a stronger programme. And it's your job to make sure that your decision makers in your national space agencies, and especially your ministers who actually make the decisions, are aware of the direction of travel that we have. Because if we can achieve this enormous goal of a 50% increase in the budget for space exploration, we'll reach 10% of the equivalent NASA budget. And that tells you something about how far we have to go still, and how far we have come already in our growth of our Europe's space exploration program. So this is the way it's organised. I talk about 4 cornerstone campaigns: humans in low Earth orbit, reaching out now with humans beyond low Earth orbit through Artemis, through our contributions to the Artemis program, both the European service modules to take humans into deep space, and our first infrastructure in deep space with the Lunar Gateway. The Mars robotic exploration program has been long running, and I cannot not mention the fact that we faced an unexpected challenge this year with the start of the war has caused us to have to suspend our cooperation for the launch of the ExoMars Rosalind Franklin rover mission. Right now, what's taking up a lot of my time, and Mahesh hinted at it, is trying to solve the problem of how we get Rosalind Franklin to Mars, despite the suspension of the cooperation with Roscosmos. But particularly relevant for this meeting is at the upcoming ministerial, we really want to strengthen our involvement in robotic exploration of the moon as a complement of what we're doing with the humans beyond low Earth orbit activities, and make a step towards the first European explorers going to the surface of the moon. So, as I said, the last ministerial was an enormous impetus, a 1/3 increase in the budget related to space exploration, and that allowed us to make some very strategic decisions to be a major contributor to the Lunar Gateway, to provide 2 out of the 3 habitation modules for the Lunar Gateway with IHAB and ESRIC. And ESRIC will also provide a refueling capability for Gateway to keep it operational well through the 2030s. and also the windows that would allow the astronauts to look down from their extraordinary vantage point in this famous non-rectilinear halo orbit down to the surface of the moon. But it's also allowed us to be a player in what for me is also a step towards human exploration, and that's the first round-trip mission to another planet with Mars sample return, to go down to the surface of Mars, collect samples and return them to Earth. And that project is also well underway now. But we've been reflecting on where we're going in our space exploration program, and many of you, I'm sure, have heard about a Terra Novi 2030 plus strategy, which are huge exercises involve representatives of the science community, national agencies, and industry developing the steps towards the future of Europe in low Earth orbit, in lunar exploration, and one day humans on Mars, and how we prepare that with the younger generation that's coming in right now. So I'm always asked, what is our end goal of lunar exploration? And I have always said it in all my talks for a long time, that for me, just as we today have Antarctic research bases tackling many important scientific questions for planet Earth, I believe eventually there will be a lunar research station, a lunar base of some sort, as a permanent infrastructure on the moon. And we want to prepare European astronauts, European science and technology to be part of that eventual vision, however and whenever it happens. That's great to have a long-term vision. An Antarctic research station started to happen 50 or 60 years after the first exploration of the South Pole. So we're getting to the stage where we really ought to be thinking about a permanent infrastructure on Earth's 8th continent, the moon. But it's great to have a vision, but what we need to have a strategy to enable that vision, and it has 3 prongs for us. The first that I want to emphasize is this possibility of regular and sustainable robotic access during the 2030s. The only way we can achieve our goals is to be a reliable but also visible partner to international agencies, and especially NASA, in the sustainable exploration of the moon. And for us, a critical milestone or waypoint on this journey is our ambition set out in the Director General's Agenda 2025 for ESA to have the first European on the surface of the moon by 2030. Through our participation in the Lunar Gateway, we have 3 seats on Orion, so European astronauts will fly on Orion to the Lunar Gateway, but obviously that's only a step towards the steps or boots on the surface of the moon. Now, again, a strategy is fine, but it has to have a bit of a finer level of definition than that. And so we think about what are the capabilities we need to establish to enable this vision. I talked about transportation, but there's also the need to have permanent infrastructure. And the first elements of infrastructure, we believe, are likely to be lunar communications and navigation. If you can rely on there being high bandwidth communications, and if you can rely on there being a navigation capability in orbit, it clarifies the design of your surface infrastructure and reduces the amount of unnecessary space tech hardware you need to take along if you're undertaking, for example, a robotic mission or on the surface of the moon, or indeed in orbit. But we also need enabling technologies such as power and mobility, and a very interesting thread. And we had only a few weeks ago the latest edition of the Space Resources Conference in Luxembourg. So the subject of preparing for space resource utilization is a very interesting research topic. But of course, most of you are scientists, and the stepwise scientific utilization of the moon is a high priority. But we also need to develop the skills and operational capabilities for our astronauts to operate successfully on the moon. And all of this is going to be enabled through international partnerships, yes, obviously, but increasingly partnerships with business. And several of our actions involve partnerships with business. And the first of those, for example, is the Lunar Pathfinder mission, where we have a European company building a lunar communication satellite. We are agreeing to use it. We're in the process of finalizing an agreement with NASA, where NASA will also become a user of a European lunar communication satellite. But right now, our key role is as a critical partner in Artemis. As already mentioned, the Artemis 1 mission is preparing for launch later this summer, and we're incredibly proud to be partnering NASA in this program and to have the European Space Agency logo on the top of the first flight because of our provision of the service module, the power and propulsion to support astronauts as they head out towards the moon. But our structure is, where do we go? Our plan is, where do we go from our access to cislunar space with participation in Artemis, the European service modules, our contributions to Gateway. The next things we think we need are indeed the sustainable access to the surface with robots, the communications and navigation capabilities, and to develop operational capabilities for the surface of the moon. And this is going to keep us busy, certainly for the next 10 years. And prepare for this this eventual goal of a surface infrastructure, which implies extended mission duration, which implies night survival capability. It implies much enhanced surface capabilities, mobility, pressurized rovers, and so forth, and sustainability and utilization, particularly meaning power, data communications, and so forth. So, to build this strategy, we need science and we need to do technology. I mentioned space resources, and I just pick out a few examples on this slide of some of the relevant technologies we're working on. So space resources is a key example. The little illustration is showing before and after processing of simulated lunar regolith to remove the oxygen and leaving metallic metals behind, using a particular electrochemical process which has been developed in Europe. I'll say more about the scientific activities in a moment, but we have a number of scientific payloads going to the surface of the moon through international cooperations. We are in Europe working on independent radioisotope technology for heat and power for exploration. And there is also a long-term vision, and several companies now working on the possibility of nuclear power for exploration. But we also need to think about what science we put in the hands of our astronauts, on what medical and operational support technologies. So in messages, we're working in all of these areas. We need to do a lot more, but we have the building blocks to support the vision of lunar exploration. And here's a kind of menu of the upcoming scientific contributions to exploration that we're planning, payloads that are either already installed, in the case of EMS, aboard the astrobotic Peregrine lander, and several other important payloads related to understanding the lunar surface environment that are upcoming, as well as cooperations with NASA, JAXA, and the Chinese National Space Administration. So it's a broad program of scientific objectives. But in order to achieve this exciting goal of European boots on the moon, we are planning and proposing at this ministerial a very ambitious program, a series of missions using the new European Large Logistic Lander, something that's capable of delivering 1.5 tons of payload to the surface of the moon, something that could give Europe autonomous capability for exploring the moon, but a contribution also to Artemis that could deliver logistic materials to support sustained exploration. So, for example, to emplace key equipment, logistics, food, water, whatever, on the moon before the astronauts arrive. And so the key decision for this ministerial is to whether go ahead with this project, and it opens up many exciting possibilities for the next decade, because alongside the vehicle, we are considering what are the options for using that vehicle, whether it be for exploration of polar resources, whether it be for geology and geophysics, for life sciences research, for space resources research, and even for demonstrating the feasibility of radio astronomy on the far side of the moon. So multiple studies are getting underway, or some cases have started, to look at applications of EL3. EL3 is, again, a rather boring technocratic name, we're reflecting on a more glamorous name or a more interesting name for this program of missions. But all of this, and I always like to come to the end, is not forgetting the horizon goal of sending humans to Mars one day. But having said all of that and giving you a flavour of where we are today and where we're going, I think my final goal is just pass the message that we are developing an ambitious strategy and ambitious perspective for the current generation of lunar scientists, of Martian scientists and technologists, but also to prepare the way for the next generation. So having spoken for a little bit too long, apologies, Mahesh, maybe I take the last 90 seconds and hope my little video, which encompasses everything we're doing today and what we hope to do tomorrow, into some sound and images. So thank you very much for your time, and I'll try and run my video now and let's see if it works.
We're not hearing the sound. There should be if you mouse over the top, a pop-up
Okay.
that should allow for computer audio.
Oh yeah, no sound. Do you hear me still?
I hear you, but no sound from the computer.
Yay. I don't know how to stop that. How to make it work. That's a shame.
Well, what we are going to do, Dave, is probably come back to this video at the end of this session, just before the Q&A, if that's possible. Ricky can sort that out because he has got your presentation there.
Okay.
So thanks so much.
Maybe I'll leave it to you and I'll end the show now.
Yeah.
And say thank you very much and hand back to you, Mahesh.
Thank you very much, Dave. And yeah, please stand by because we have got 3 other presentations in this session. Then we are going to then invite people to ask any questions and participate in discussion. So I hope you can stay with us for the next hour or so. Okay, so let me move on to the next talk in this session, which will be given by Kathryn Hadler. Now, Kathryn is the newly appointed director of the European Space Resources Innovation Center in Luxembourg. And she got her hands very busy as soon as she joined because she had to organize the Space Resources Week. And we thought that it is just appropriate to invite her and just listen from her what is hot off the press from this meeting. So Kathryn, over to you. You have 15 minutes, and if you want, I can give you warning at 12, or you can just manage 15 minutes by yourself.
Thanks, Mahesh. I'll keep an eye on the time. I make it 10:38. So let me just share my screen. Okay. And we should be sharing. Thank you very much for inviting me to give this talk. I think David has set it up perfectly. So we can see from David's talk the importance of space resources in future space exploration strategy. And that's exactly what we are interested in at ESRIC. So in the next 15 minutes, what I will do is just give you a bit of an introduction into ESRIC, what we are about, what we are doing, and then I will summarise the key messages from Space Resources Week. So ESRIC, as Mahesh already said, is the European Space Resources Innovation Centre. We are based here in sunny Luxembourg. And I have been the director of ESRIC since the 1st of April. It's been a fairly quiet start to the job. But we've had a lot of activity, lots of fun. And in the next talk, what you'll really see is why we are focusing here at ESRIC and in the space resources community at large on sustainable use of space resources. So ESRIC itself, what is ESRIC? Well, ESRIC was formed as an innovation centre focusing specifically on space resources. It was formed officially in 2020 as a partnership between Luxembourg Space Agency and Luxembourg Institute of Science and Technology. And ESRIC exists as both an innovation centre and a department at LIST. ESA joined later on in 2020 as a strategic partner. So ESRIC exists as this partnership between LSA, LIST and ESA. And our goals with for ESRIC is that it will become a centre of excellence and expertise for science and technology related to space resources, but also for business and economic aspects. So we're interested in all of these aspects. We really promote the use of space resources in human and robotic space exploration, as well as for this future, this new in-space economy. And what's important about this is the complexity of space resources systems. So we talk a lot about the use of space resources. I know there's a lot of talks in this meeting in the next 3 days that are looking at resources and characterization and extraction of resources. When we look at these systems, an entire end-to-end space resource use system is complex. The diagram you see on this slide on the right-hand side is a very much simplified version from the ESRIC GGAP assessment report that was released last year. The original diagram is fabulously complex. You can spend a lot of time staring at this diagram. And like I say, this is a much simplified version. But what we see here is that it's not just about characterization and acquisition and extraction of value, but we also need to think of the infrastructure, the manufacturing, storage and delivery, and life support, and all of these different units are interconnected. So what we see from space resources systems is that it's fundamentally about resource extraction and use, but in these resource scarce, hostile and pristine environments, and that's an important point that I'll come back to later. Space resources will both produce and enable scientific discovery, but also economic activity in space, as David has already mentioned. But what's really important here is that it requires a community effort. This is not a task. This is not something that can be implemented by one research group, one space agency, or one company alone. It requires a genuine community effort to make this happen. And this is where ESRIC fits in. So what we're doing at ESRIC is developing activities in 4 areas that will support the European space resources community. And so I'm just going to run quickly through each of those activities. In terms of research, now we started really a year ago with real activity in ESRIC. And so we're building up our research activity, and we all know how that setting up research activity is a slow process, but we're building research capability across the whole value chain of space resources, focusing on novel technologies, but also in integrated systems. This idea that these are complex systems that must be integrated and must work well. In terms of research infrastructure, we have laboratory capability, and we're building laboratory capability. Currently, we are hosting the hydrogen reduction system, but we will also host some molten salt electrolysis systems, FFC Cambridge process that David referred to in his talk. These are being procured by ESA and hosted at ESRIC, and as such, they will be open in due course to European academia and industry, and I think that's a really important point to note. We will also host the dirty thermal vacuum chamber that is currently undergoing feasibility studies at ESA, and there is talk of a new terrestrial pilot plant facility that will allow us to explore these systems of different units that will provide space resources. So we are building these research facilities that will be a facility for European academics, but we're also starting up our own research. And here's some examples of the projects that we have currently running, very much looking at those end-use applications or extraction of value from space resources, so producing oxygen, producing metals and using metals, and looking at lunar infrastructure. Currently, we have partnerships with Airbus, with Air Liquide, and with Mana Electric on these projects, and this is an area that we will see grow into the future. But it's not just about these individual units, so extracting oxygen from regolith or using additive manufacturing to produce infrastructure. We need to think of these processes together in a system, an end-to-end system. And so with that, we have a new major research programme that is starting with my appointment, and this is funding that came from the National Research Funding System in Luxembourg, the FNR, and this will create an entirely new research group. So this project is based on sustainable and responsible use of space resources. And rather than focus on these areas in this diagram in the white here, the construction, manufacturing, and extraction of value, we're focusing instead on those linking projects. So the enabling technology, the beneficiation, my favourite subject. I could talk for days on beneficiation, but those technologies that will be required to interface between systems, that will be required to make sure that these systems work at their optimal, with their optimal feedstocks. We also need to think in terms of circularity, so in terms of recycling and modular design, and that's a topic that we will address very much at ESRIC, in addition to integration and optimization of these systems. But one of the other things that we need to focus on is environmental legacy. And as a conference of scientists, you will be very, very aware of the need to minimise environmental legacy and really clearing up after ourselves. I'm from the terrestrial mining sector originally, and from the terrestrial mining sector, we know the legacy of extraction and use of resources, and we need to take steps to make sure that we minimise our impact on the moon and beyond. So that is a new research programme. We are recruiting. If you are interested in PhD or postdoctoral positions, then please keep a lookout for job opportunities that will become available in the very near future. But it's not just about research. As I said, the point of ESRIC is that we also are active in business and economic aspects. And so to support business, we have the Startup Support Programme. It's the world's first business incubator programme specifically for space resources. We are currently halfway through the first phase of pre-incubation. So there was an open call. 5 startups were put forward into a pre-incubation phase of 3 months. And when that comes to an end at the end of June, one of those 5 companies gets put forward to a full 2-year, €200,000 incubation phase to develop that business into a space resources focused business. This is a programme that's run in partnership with ESA and also with Technoport, which is a business incubator here in Luxembourg. The next round of that will be opening in across summer. So if you have a startup idea, then keep an eye out for the next call for the competition there. And as our role in bringing together this European space resources community, we've developed a knowledge sharing platform. This is in existence. It is a work in progress at present. It was demonstrated. It was demonstrated at Space Resources Week. And we will be building capability and demonstrating the value of bringing together all of the very dispersed and diverse knowledge that exists around space resources. And moving into our community events, one of the events that we have been hosting over the last year and a half, it was launched last April at Space Resources Week, is the ESRIC Prospecting Challenge. This was an open competition for teams to develop and demonstrate their prospecting capabilities. And so the first round was held in ESTEC in November. The final round, so it's 5 teams left in that competition. The final round is being hosted in Luxembourg in September this year. They're basically filling the Rock Hall, which is just across the way, big concert hall, turning that into a huge lunar yard. I've seen the plans. It promises to be quite spectacular, and those teams that are taking part will demonstrate prospecting capability for a prize. Let's move on to the flagship of our community events, and it's the Space Resources Week. So Space Resources Week happens annually. It was held at the beginning of May, so just a couple of weeks ago. It is the largest event that is fully dedicated to space resources. I know that there's huge amounts of people in this conference also, and that many of you may have been present at Space Resources Week. There was about 300 to 350 physical attendees, and we had about 650 online participants. So it's a really testament to the huge interest that there is worldwide in space resources. Part of the large numbers is because it's free to register, and I think that's really, really important to make sure that we are reaching out and attracting as many people into this community as possible. We had over 100 presentations and 27 posters in 2.5 days. It was a packed 2.5-day program. It felt much longer than 2.5 days. I think everybody would agree, but it's really, really brilliant to see that community come together. Mahesh inferred that I had organised it myself. I did not. There was a brilliant team of organisers from ESRIC, but also from LSA, ESA and LIST. And what's also important is we cover not just the scientific developments, research developments, but also technical, business, legal and economic. So here's my key my key points. I know I've got 2 minutes left. I have 2 more slides, so bear with me. The theme of this event was sustainability, and when we talk about sustainable space exploration, often that means a lot of different things. So we can talk about sustainable space exploration in that we use resources to avoid the need to take everything we need with us. It can mean sustainable economic activity, and it can mean sustainable resource extraction and use. That means meeting the needs of today without compromising the needs of future generations. And in fact, we touched upon all of those topics in Space Resources Week. The key trends from this conference, and there's a big disclaimer here, this is in my opinion, this is not the official view of the organisers, so rather subjective, but I think my key trends from the conference was that we still see this broad range of activity. Actually, there's a huge amount of activity in this field looking at extraction of value from regolith, so oxygen production, additive manufacturing, sintering and so on. There's a really broad and exciting range of activity in this field. The focus of those talks very much focusing on the moon. The majority of this is focusing on the moon, followed by Mars, and asteroids formed only a minor part of that conference. We still see lots of innovative concepts for novel extraction or novel application related to space resources, for example, biomining. But also what we see is a greater presence of industry who are active in this field, both startup and established industry such as Airbus and Air Liquide. And here are the key take-home points. Again, my opinion. Here's the caveat. This is purely my opinion. I'm open to other conclusions as well. Key messages here. Regolith simulants are a hot topic. It is a topic that comes up time and time again. It may come up during this conference. Access to simulants in terms of cost and delivery times, repeatability of experiments, people making their own simulants, kind of regulation of the simulant sector, which simulants do you select? These are all topics that have been that are very much at the forefront of people's mind in the research community, and it seems to be particularly an issue that we are having in Europe. There's no conclusion to this as yet, but as I say, this is a key topic. I think one of the other messages is that actually having that broad diversity of people at the conference is important. Having the legal experts there is important so that they can understand what's being developed in the scientific community. There's no way we can avoid the legal and ethical implications of space resources. So I think bringing everybody together into one workshop is important. And finally, greater integration is required. So we still see a lot of the research naturally focusing on individual units, individual processes. But we see from that beginning that space resources systems are very complex. So we need to also think in terms of systems. What do these systems look like? What are the weak points, bottlenecks? Potential issues into the future with implementing these systems. That's certainly something that ESRIC are interested in, and the ESA terrestrial pilot plant will address the issue. So my final point here is that I come back to the point that that space resource use is about resource extraction and use in a hostile but pristine environment. And so in this community, we've got an opportunity to do amazing science, but we also have a responsibility to demonstrate how space resource use systems can be achieved and implemented in a way that minimizes our impact and legacy for the future. So thank you very much for your time.
Thank you very much, Kathryn. And like you alluded, you can never run anything successfully without a very able team behind you. So I certainly expected a huge amount of effort from the team that actually organizes Space Resources Week, and congratulations for putting that program in such a wonderful manner. I think there is a question for you, but we are going to pick that up in the panel discussion, if that's okay. And 10 years ago, who would have thought we would be here with the Space Resources? So I often find myself that there is so much richness in Europe that is often hidden, and somebody needs to just bring it up and make it visible to others. So good luck with your effort, and we look forward to hearing from you, in our future meetings and further participation. And perhaps there could be some two-way dialogue between this meeting and Space Resources Week. There must be something common there. As you can see, there are very common people who attended both meetings, right? So let's talk more in the panel discussion and beyond. So we are slightly behind time, but not a problem, because we did think that this particular session will need certain amount of flexibility. So we are still under control, nothing to worry about. Very pleased to introduce my colleague, Jessica Flahaut. And Jessica was a co-author on an ESA white paper that was entitled Planetary Science Using the Moon as an example. And when I read that paper, I felt that it was so well written that it almost encapsulated everything that we were trying to do in Europe with regards to lunar exploration from a scientific perspective. And so we felt that we should actually hear about this paper a bit more. And so Jessica agreed to actually give that presentation on behalf of a co-author. So Jessica, take it away.
Thank you, Mahesh. Good morning, everybody. I hope you can hear me well. Okay. So it's my pleasure to talk today about the Planetary Science Roadmap of ESA, which was later relabeled as a white paper. And this reference document was actually written by members of the science community. I want to take this opportunity to greet my co-workers, Caroline and Jan, which are online today. And we were invited to do so by the SciSpace team of the Human and Robotic Exploration Department at ESA. So the document was mostly written in 2020 during the pandemic, and it was reviewed and published online by ESA last year. So some of you might already be familiar with the SciSpace program, which focuses on results from the ISS, non-ISS space platform and space environment analog. And the aim of this program is, of course, to help prepare future space exploration with science experiments in the space environment. And all of it in the framework of these 4 cornerstone exploration campaigns that were presented just before, which are part of ESA HRE department and illustrated here. So SciSpace prepares and delivers multidisciplinary science activities, some of these pertaining to planetary science and exploration. And in an effort to review and expand recommendation on future research focus area, the SciSpace team has invited us to write a series of roadmaps or white papers. Now, these white papers are all publicly available online. You can see the address here. And they cover a range of topics. And today I will talk in more detail about the Planetary Science White Paper, which is number 3 of the Physical Science White Paper series. So this white paper number 3 was actually written by a larger team because it discusses key science questions for the Moon, but also for Mars and asteroids. as well as priorities for the HRE Sci-Space program, benefits for the Earth and the industrial relevance of our suggestions, and also recommendation on how to achieve and address these key science topics in the short, middle, and longer term. Today, I will give you a quick overview of the section that was written that deals with the moon and that I co-wrote with Caroline and Jan. But again, the document is available online publicly, so feel free to check it out by yourself. So we all know that the moon is a geology history book, preserving information about the formation of rocky planets, the Earth-Moon system, and also documenting the solar system geological and astronomical events for 4.5 billion years. Since a number of reference documents discussing science of the moon and on the moon and from the moon already exist, we largely based our study on a thorough review of those documents, and we try to update these documents with results from more recent missions to define 6 key lunar science questions. So these science questions, which are bombardment history of the inner solar system, interior structure of the moon and lunar seismicity, a range of geological processes, regolith processes, lunar volatiles, and atmosphere, dust, and plasma environments, are not listed here in any particular order. We built a requirement matrix that defines the starting points that will ultimately define the scientific capabilities of ESA HRE's missions. So let's start exploring the matrix that we built with the fundamental question A1, which relates to the bombardment in the inner solar system. So the lunar surface provides a largely complete record of the impact history of the Earth-Moon system. And several aspects of this record are of compelling science interest, including whether there was a spike in the impact rate between 3.8 and 4.1 billion years ago, so whether there was a so-called late AV bombardment, or also questions about more like recent bombardment and what is the impact flux of the last billion years. So in order to address these questions, we listed in column 2 here some possible experiments to be carried out. And of course, to address this specific science topic, we will need in-situ dating and even samples to be returned to Earth for dating in laboratories. So sample of key locations such as SPA, of course, to anchor the period of impact-based information, but also sample from younger areas. So in column 3, we listed the relevance of this addressing this topic, and not only in terms of science. Of course, this is important for space exploration because the lunar chronology is what we use for dating every planetary surface in the solar system. But there is also interest in, of course, assessing the present hazard on the Earth and on the moon if we put infrastructure up there of having some current impacts. And we foresee a number of technology drivers that will have to be developed in order to fully address this science topic. And in the last column of this matrix, we propose some recommendation in the short, medium, and longer term, and of course, an example in the short term in order to address this question of chronology is to participate in the analysis of samples that will be returned by Chang'e 6 and that have been returned by Chang'e 5. But in the longer term, it is key that ESA develop doing a sample return mission from a key area, a key geological unit that we can date. So I will go a bit faster with the second question. Now you understand the structure of this matrix. And so the second topic of interest is obviously the lunar interior, but also tectonics and seismicity on the moon to try to address questions such as the thermal state of the moon, but also its evolution, its current level of seismicity, the sources of moonquakes. And this can be achieved by globally distributed geophysical network at the surface of the moon. Okay, third questions is here a mix of geological processes that we gathered into one topic. So this deals with the diversity of the lunar crust and what it tells us about the formation and the evolution of this envelope, but also about volcanism on the moon and impact cratering. And here there are a number of experiments which are totally suitable to address these topics, such as continued observation from remote sensing platforms to monitor, for instance, changes over time, but also obviously some in situ and sample return measurements in order to address these questions. Okay, science topic number 4, it is about water and other volatiles at the lunar surface. So we do know that there is water in various forms on the moon, and the origin, whether it's from impact, solar wind, volcanic degassing, the vertical lateral distribution, the abundance, the resource potential, age, transportation, accumulation cycle of these lunar volatiles are all poorly constrained, and they could be addressed with both in situ measurements and or sample return from polar regions. And obviously there is a number of technology driver here, such as the development of sample containers that can handle ice and volatiles. Okay. Fifth topic is regolith processes. So despite numerous landed and orbital missions, we still have some key questions pertaining to the formation mechanism of regolith on ELS bodies, its modification by space weathering, its physical properties, which is absolutely key to enable future lunar exploration, and also its lateral and vertical variation. And so these can be addressed by analysis of return samples, as well as in situ analysis, especially of unexplored area or not well characterized areas such as polar locations, feldspathic islands, younger terrains, pyroclastic deposits. And we also argue that a mobile element is key to determine all the variation in the regolith property in situ. And the last topic is atmosphere, dust, and plasma environment. So the lunar atmosphere is the most accessible surface boundary exosphere in the solar system. So it offers insights into a lot of surface mechanisms, such as surface sputtering, meteoritic vaporization processes, exospheric transport processes, gas surface thermal and chemical equilibration. It's a dynamic system and also plays a role in the transportation and deposition of volatile elements. And still the composition, source sinks, the variations due to impacts, lunar cycles and solar activity are poorly understood. So there is a number of things to do here to characterize these fragile environment, especially before we do more activities at the lunar surface. So in addition to these fundamental aspects of lunar science, we also argued that the moon may be used as a platform for carrying out science investigation of fundamental physics and astronomy on one side, but also different aspects of life sciences, such as physiology and medicine, habitability and survivability studies. So finally, the moon is also a destination for technology research and development, in particular for developing in situ resources, manned exploration, and to use it potentially as a waypoint for the human exploration of Mars. And we identified key steps for this future long-term exploration that will require the development of enabling technologies that are listed in the document, such as precision landing, of course, also the ability to survive lunar night and explore permanent shaded regions using, for instance, nuclear power. So developing some power and heating system that will enable this. Developing some capabilities to land heavy payload masses, such as what the European Large Logistic Lander is planning to do. Develop some deep drilling capabilities, sample return capabilities, especially cryo sampling. Return would be a big asset, not only for lunar exploration, but also would be useful for the exploration of other destinations in the solar system. And of course, one key aspect of that we suggest should be a priority in the coming years is the development, of course, of in situ resource utilization. So based on these findings, we made also a list of recommendations that could be achieved in the short, middle, or longer term. I will not go through the full list. I put here a picture of the prospect drill because I think it illustrates a number of these topics, such as, well, the participation, of course, in upcoming lunar mission through collaboration with international collaboration, but also try to support the development of payloads in the framework of the European Large Logistic Lander, for instance. Support continued and improved remote sensing of the lunar surface, prepare for future sample return mission, develop surface experiments such as geophysical network, and of course, these recommendations also include the implementation of new capabilities such as, for instance, deep drilling. So in conclusion, we acknowledge that lunar missions have driven significant advance in our understanding of the nature, formation, evolution of our moon, which is also a Rosetta Stone for understanding the formation and evolution of other planetary bodies. But these advances and all the recent missions have also led to new and more refined science questions that can be addressed in the next steps if we also mature our technology. We expect some major scientific breakthrough to come from these new missions that will explore the moon this next decade, including, of course, the return of humans to the lunar surface. And we make just a list of recommendation of steps to carry out to achieve these by developing enabling technologies, of course, and taking opportunities of the international collaboration. Thank you for your attention, and don't forget to get the document at this address.
Thank you very much, Jessica, right on time. So I think we now have got plenty of time for a panel discussion. So could I ask all the presenters to switch on their video if they can? And I also would like to invite participants to actually type their question in the chat box. I already have got 3 questions ready to go. But before actually I do that, could I ask Ricky to actually play that video, and that will give everybody time to type their question in the chat box should they wish to. So Ricky, are you able to play Dave's video? It is about 2 minutes, I think.
Yes, I can.
Great, thanks. And people get typing your questions. Brilliant. I don't know about others, but yeah, I had my hair rising back of my neck by watching that, and it's just so much excitement. And some of those people there were not animations; they were real people earlier, which is amazing when you know them personally too. Great. So I think we have got time for some discussion, and I can see that there are a couple of more questions that have come in. Let me get the ball rolling first with Dave. Dave, you presented a fantastic vision, and you alluded to, that you will be asking for almost 50% rise in the budget. And given everything else that is going on at the moment in the world, how challenging that might be. That's one thing. And what actually this community, we as interested people, I just don't want to say scientists, because we are a bunch of people here. We are not just scientists. We are interested in technology, we are interested in education, we are interested in science of the moon and whatever moon can enable us to do for the rest. So what can we do to contribute towards realizing your vision that you presented to us?
Thank you, Mahesh. I mean, it's a great question. You can do a lot is the short answer. By making sure you could explain, if you crashed into a minister in an elevator, the classic elevator speech, what would you say? How would you say, why is it important? A minister is interested in what are the opportunities for their country, what are the commercial opportunities, what are the jobs, what's the benefit for the society as a whole. So do you know what you would tell the minister if you had the chance? Are you working with groups such as ESSC is a perfect example, or with through your national channels to pass the messages to those that are making the decisions? Do they appreciate what you're doing? Have you invited them to your laboratory to find out what you do? So communication is the story. We're all responsible for it in different ways. We all can do a little bit towards that. Is it a challenge? Yes, it's an enormous one. We're in a war in Europe on our continent for the first time in a long time. And we have the challenge of inflation. We have a challenge of many, many other challenges. But the message that I always give is the money we spend is not launched into space. It's spent here with scientists like yourselves and engineers and lawyers and business people and all the rest of it to create economic opportunities. We know that every euro you put in, you get 2 to 3 euros of economic activity as a result of investment in space exploration. And finally, it's about what Europe is as a continent. Are we going to watch all of these events happening due to actions by the United States or China or whatever, or do we want to be part of it? What's the future of Europe? And it's as fundamental as that.
Right. Thank you so much. Quite comprehensive, Dave. I think we have a lot of work to do together, and whatever we can do from our side, I think, we should strive to do that. And good luck with your ministerial. I'll be watching that with great interest. Shall we move on to the next question? So I'm going to bring in questions as I feel they might actually flow in some sense. So there is no priority here. It's just, how it might lead into one to the other. So, Kathryn, there are a couple of questions from ESRIC's point of view, and it kind of flows from what ESA is trying to achieve and where ESRIC might play a role. And so there was a very quick question from Sylvester, who asked a question about your startup program. And I worry this is probably driven by Brexit consideration, perhaps, but I don't know. But the question was whether somebody from the UK can actually bid into that startup program.
The good news is yes. With one thing that Brexit hasn't affected. So the startup support program is open to anybody from around the world. So one of our 5 startups is currently in the US, one's in Poland. So that first, it's open to anybody. That first 3-month pre-incubation phase, the company can be based anywhere, and then if you make it through to the full 2-year incubation phase, then you have to be registered in Luxembourg.
Right. Okay. So that was a simple and a straightforward answer and a positive one. So that's great. Another question from our SOC chair, Evelyn Fury, and she asks, can we make sure that agencies, private companies, and industrial partners all work towards a common goal in terms of sustainability and planetary protection? Now, Dave and Kathryn, I mean, I guess it falls in your court, but others are free to contribute. But if I can start with Dave, perhaps.
Well, sustainability question is a great one. Ultimately, from a regulatory point of view or a legal point of view, we go back to the Outer Space Treaties of 1967, which set out the fundamental legal basis. Now, that is one of the goals of the Artemis Accords is to interpret the 1967 treaty and make it clearer what certain countries believe is the correct application of that treaty. What are the norms of behavior? What are the appropriate ways of operating? We at ESA are very, very much focused on sustainability as an organization. So hence the Space Safety Program, which is exactly tackling issues about orbital debris around this planet. We're intending to move to a kind of zero impact approach where for every time we launch something, we will remove something out of space from orbit in order to protect the immediate space environment. And then, of course, for the protection of the planets as scientific destinations, then we turn to COSPAR, who set out the planetary protection principles. The challenge, of course, is that the legal enforcement of one country relative to another country is not something that is easy to do because each country, as a sovereign nation, implements its own legal approaches to regulation. I used to have a life as a chief executive of the UK Space Agency, signing the launch licenses for UK-based satellite activities, and we followed the principles of regulatory principles of the UK. But each country has slightly different approaches, and some countries don't even have a space law, which can make it complicated.
So, Kathryn, yeah. So, yeah, how can ESRIC, help in this case?
I think to follow on those comments, one thing that is important to note is that actually building sustainability into any system is not just about doing the right thing because we are required to legally, but actually it will make a more economic system in the long run. If you're taking all of, let's say, your regolith and using it in some way such that you minimize waste, that actually is a more economically viable approach than just churning through and making one product and leaving the rest. So actually sustainability as a concept for building sustainable economic activity or sustainable systems, I think is very important, that actually that there's an economic argument for it also.
So basically it should be by design right from the beginning.
Exactly.
Okay, that's great. Okay, let me just move on swiftly because we've got a few minutes left. I hope people won't mind if we go 5 minutes because we've got 15 minutes of break after that. I think there are at least 2 other questions I just wanted to pick up on. There was one question from Katie Joy, and I think Katie was essentially asking that, Dave, you mentioned that in Europe, we don't want to just stand and see the world pass by us. And we know that Artemis program is taking shape. And the US, you yourself mentioned that. So I think her question was that what are we doing in Europe to make sure that, we get a fair share of that action?
Yep, thanks, Katie. So the answer is a whole set of formal mechanisms. So if we take the Lunar Gateway, there is a Gateway Utilization Board, which is an international board, which allows, which jointly discusses the scientific utilization of the Gateway. So Europe is contributing certain instrumentation, the US is, other partners are. The access to that data is managed on an international basis. And so it ensures that Europe has full access to the scientific data coming from Gateway. And my expectation is something similar will evolve for lunar surface science. My colleague Jim Free and I were discussing last week face-to-face in Paris. We recently signed a statement of intent to further cooperation looking towards lunar surface activities. It identifies 3 areas of cooperation: lunar transportation, which is referring to ELF, lunar communications and navigation, which is our proposed Moonlight cooperation, but then lunar surface science. And I think you know James Carpenter, and he's your point of contact to know what's going on in the planned scientific domain.
All right. Thank you very much, Dave. And we very much hope that those lunar surface operations will yield sample return that the European community is very strong at and is really hoping to get an opportunity to work with those. But these are incremental things, so hopefully that one will lead to the other. Now, I know there is no specific question for Jesse's presentation, but I think there are a couple of questions which link to it. So if I might actually bring you in, Jesse, into the conversation. There was a question about whether, and I think Dave has to come in towards the end on this. There was a question from Caroline Wonder-Bogart that given China is going for a direct access to the lunar surface, essentially short-circuiting and not going through a gateway type structure, would it make sense for ESA to actually go through gateway and to the surface operation? The reason I'm asking this question to Jesse is in the white paper that you co-wrote, from your point of view, what are the big questions that could be addressed with or without gateway?
Well, I think clearly the gateway is facilitating lunar surface exploration. It's gonna make it easier to probably to return samples and to have just not one sample return mission, but return a significant amount of samples, and to also have more manned mission to the lunar surface. And these are key to achieve some of the science topic we discussed in the white paper. So I think a number of part of these questions can be addressed like we do now with remote sensing observation and robotic exploration. But we know the step forward is to have humans to the lunar surface and to have samples returned back to Earth. And I think that can be facilitated greatly by the lunar gateway for sure.
Okay, great. That's nice to hear. So Dave, from a logistical point of view, the question is, can we expedite the lunar exploration, the surface exploration, by actually bypassing the gateway stage, or is gateway critical to ESA's strategy for ultimately leading to surface operations?
Yeah, I always call Gateway the base camp for lunar exploration, where the moon is at the bottom of a gravity well. Going to the surface of the moon with humans requires an awful lot more propellant and technological capability, and infrastructure, permanent infrastructure for communications, for supporting the astronauts is a valuable stepping stone towards sustained lunar exploration. And my vision of the lunar base one day, it's not going to happen tomorrow. Nobody's planning to build it tomorrow. China certainly isn't. You've got to build the transportation capability first. 90% of the cost of lunar exploration is transportation. And it is also to be pointed out that part of the objective of the Gateway is also to provide infrastructure that is preparing for going on the route onto Mars. And I don't think the Gateway will be the only lunar station in orbit. Eventually, I think there'll be more than one. So yes, the Gateway makes sense if you want a sustained exploration campaign. Sustained as opposed to sustainable, two different things. But sustained exploration, yes.
Great. Great. Thanks very much. So I think I am going to draw this particular session to a close in order to sustain this meeting for the next 3 days and give people a break for... Oh. Siri also thinks that I should give people a break. So we'll take a break for about 8 minutes and we'll be back at the top of the hour when our chair for the next session we'll continue with the proceedings. And I would like to thank all the speakers. And one thing that I don't like about the virtual meetings is we can't really give a proper clap for all the presenters. So please accept our gratitude for your participation. So thank you, and see you all at the top of the hour.